Okay, hello everybody. So we are doing absolute values again. In the last lesson we discussed what happens when your A value is negative. That was quite interesting. We got a flipped, upside down looking absolute value graph. But I think another observation to take from that, which is what we're going to be focusing on today, is what does the size of the A value do and how does it aid the interpretation of the graph? We're then going to be dealing with different kinds of salient points because the only salient points we've dealt with this far is salient points of 0, 0. And remember, we discussed that a salient point is where do your two graphs actually meet. So we're going to be talking about where they meet at different positions and different points, which is very cool. Furthermore, we're going to be discussing a few absolute value inequalities, which are really helpful, as well as what to do when you get two absolute value equations and how to plot them both on one graph, even when you just get one absolute value and one straight line that you will have to plot. So that's going to be fun. Okay. So the example that we're using is y is equal to the absolute value of x minus 5. This is example 3. And, that's not in one absolute value. So, our first equation is going to look somewhat like this. At this point, we know it's quite easy. We have x minus 5 if x, colors, if x is greater than or equal to 0, and we have x equals negative x minus 5 if x is less than 0. It's very important to identify in this sort of absolute value functions equation that we are dealing with an absolute value of x. So the absolute value is not encased around x minus 5, which becomes very important because I was going to make that mistake, and it becomes very important in terms of the orientation of your graph. Okay, so we have the baseline as to what our two graphs are going to look like. And from this we can determine that we do have a graph with a negative gradient, which is going to be the second one. That does not look like that. Lovely. Okay. So, just by nature of me looking at this graph, I already know it's definitely going to be upwards, and it's definitely going to look like this. Now this brings a very important observation to the table. What does this 5 do? This 5 is simply just moving the graph up or down. So it's translating the graph up or down. So when we talk about negative 5, we're actually just talking about your salient point and how it changes. And so now your salient point is going to be at 0, negative 5, because of that value, which we call the Q value, by the way. Okay, now we have our two equations of our graph. So you can already see how I've already gotten the framework of a graph just by looking at it. Let's talk about the first graph. So I can already see that x minus 5, this one over here, is definitely going to have the positive gradient. So we're definitely looking at, sorry, that must be a lot. We're definitely looking at this. So y equals x minus 5. So we know that our value has to be a positive x value because right now, as it stands, it's in quadrants 2 and it's in quadrants 1 and quadrants 4, sorry. And so we're going to say something like y equals 1 minus 5, and then you get y equals minus 4. So we can draw a little point. We can say 1 minus 4. Remember, I explained to you how important it actually is that you are writing your points down. Then we're dealing with the second equation, which is y equals negative x minus 5. And the key here is to choose a negative x value because obviously now we're dealing with quadrants 2 and quadrants 3, so we're working here. And so you must choose a negative x value, and this is going to be your negative gradient, so that's quite important. And so you'd say something like negative 1. Remember, I told you just don't be extra. And then you have 1 minus 5. And so now we have when x is negative 1, that's interesting, y is negative 4. Interesting observation to make. Okay, so we've spoken about how the salient point changes. That is something that's quite cool. Always make sure to do your salient point in another color. Okay, let's deal with an example that is now flipped around but also has a salient point until we go into more equations where we're actually going to have our salient point incorporated into the absolute value, which does not get complicated, it just is a little bit different. Okay, so now we have an example which is y is equal to negative 2 times the absolute value of x plus 4. Just by looking at this equation, we know that our salient point is going to be 0, 4, because we already explained that's what the Q value does. That's great, that's very good. We also have this negative 2 value here, which is your A value. And we know from way up here that when your A value is greater than 0, you're getting a V. But this happens to be less than 0, so you're actually getting an upside down V. So see what we can just determine from just looking at the equation. Okay. Also make sure to label, like what I didn't do. Okay, lovely. Now we're doing the same thing again. Y equals negative 2x plus 4 if x is greater than or equal to 0 colors. And y is equal to negative 2 of negative x plus 4 if x is less than 0. We can simplify that further, so basically just 2x plus 4. Okay, so just from this, I know exactly what my graph is going to look like. Basically at this point, all I need are points, because now I know that my salient point is definitely 4, 0. I know that my shape definitely is downwards, so I'm going to have one arm protruding this way, and the other protruding the opposite way. And now we're just doing the maths. So this arm over here definitely has the negative gradient. So we go to our equations and we see which values of y, which equation of y has the negative gradient, which is definitely going to be the first one. Then we attempt our second equation, our second line on the graph. Then we say, where do we have a negative gradient? Where do we have a positive gradient, and the positive gradient is definitely y equals 2x plus 4. Fantastic, we're doing great so far. So let's start with the first arm, which has the negative gradient. So we have y equals negative 2x plus 4. Substitute a positive value in because that is what the question asks of us. Because of this condition, just reminding us all what the conditions are. They're very important to remember. And if an answer doesn't fit a condition, then your answer can't exist. Okay, cool. Negative 2 plus 4 is 1. Great. So, okay, so we can draw in this arm that when x is 1, y is 2. However, we also see something that we haven't seen yet in most of these equations, which is we have 2 roots. Which are 2 x-intercepts. And this means we're going to have to find them, because usually in questions they will ask you to label the x-intercepts. They usually ask this question. And so in order to find that, you would find it any other way like you would in a normal equation. So if we're looking at the equation y equals negative 2x plus 4, in order to find the x-intercept, we would make our y value 0, which would mean that our x value would have to be, in this case, 2. And because it's symmetrical, this will have to be negative 2, 0. Okay. We can do the same thing on the other side, and we can have negative 1 times 2.